Hi everyone, this video is on mixed exercise 9 question 17. We have the curve C which has the parametric equations x is equal to 2t and y is equal to t squared. And we want to find the equation of the normal to C where t is equal to 3. Okay, so in order to find the equation of the normal, we first need to find the gradient. And then we also need to know point P, right? We need to know the coordinates of point P in order to find the equation of the normal that passes through point P, and that's the normal to C. So what that means for us is that, and also in order to differentiate this is a parametric function, so we need to use parametric differentiation. And parametric differentiation is basically needs us to to remember this formula that dy by dx is equal to dy by dt divided by dx by dt. So this means there are two components to this formula, and we want to find each of them separately. And in this question, dx by dt is equal to, so that's just simply 2 because 2t differentiates to 2, and dy by dt, t squared differentiates to 2t. Now that we have dx by dt and dy by dt, we can just substitute them into the formula to have 2t divided by 2, and that is just t. So t is the gradient function, and the gradient equation actually. So we basically got dy by dx is equal to t. And since t is equal to 3, that means the gradient is equal to 3, right? Because t is equal to 3 and the gradient is then 3. So this is the gradient. Now we have the gradient. We need one more thing, and that's the coordinates of point P, which is on the normal and C. So in order to find the coordinates of point P, we just need to substitute the value of t, which is 3, into the function of x and y, so that we get the coordinates. So that means the x coordinate is equal to the x coordinate of P is equal to 2 times 3, which is just to double check, 6, and then y is equal to t squared, so substituting is going to be 9. Okay, so the coordinates of points P are 6 and 9. We now have the gradient, we have the coordinates of the point. We just need to find the equation of the normal right now. Also, before finding the equation of the normal, remember that this is the gradient, but this is the gradient of the tangent. So the gradient of the normal is equal to, maybe it's better I write just here. So the gradient of the normal is obviously the negative reciprocal of the gradient of the tangent, which is -1/3. This is very important because it's very common, to get to this point and just use the gradient of the tangent line. So we just use the equation y minus y0 is equal to m times x minus x0 and substitute the values. Y0 is the y coordinate of the point, which is 9. M is the gradient, which is -1/3. X minus x0 is just the x coordinate, which is 6. And so the question hasn't asked us for a specific form. We can just simplify this. So I'm going to do y is equal to minus, expanding the bracket, minus x/3 plus 2 plus 9, just adding 9 to both sides, and this is equal to minus x/3 plus 11. So this is the equation of the normal. So equation of normal. And yeah, so that's it for this video, and thank you for watching.